and welcome to my first video. And today I'm going to tell you the properties of addition and subtraction of integers, which is a thing of grade 7. It's good if you're in grade 7 so you can understand it better. First property, now first we're going to do the properties of addition. The first property is closure property. So what is closure property? Closure property is nothing but when we, for example, when we are multiplying two integers, the sum, the result by adding these two integers will always be an integer. For example, what we write is that integer plus an integer is always equal to an integer. Now, I will be just giving you an example, short example. For example, if I have 8 plus minus 9, so if I do that, my answer will be minus 1. So here I can see that an integer added to an integer is an integer. So we understand that integer plus an integer is always an integer. Now the second property we are going to do right now is commutative property. Now what is commutative property? When we add an integer, for example, if I am adding a plus b, so the sum that will come is equal to if I write b plus a. Now this will be better understand if we write an example. For example, I have to do 6 plus 9. So we know that the sum which will come is 15. But if I write 9 plus 6, the sum is 15. So we can see that whatever the order of the both numbers, of both integers is, the sum will always be equal. But commutative property is basically which we use only in subtraction. Addition. Addition. Okay. So this shows that 6 plus 9 is equal to 9 plus 6. I think you have understood it. I will just show that. Yeah. Now the third property we are going to just do right now is associative property. So what is an associative property? If I have three integers, for example, a, b, and c, so this is something which is same as commutative property, but commutative property talks about two numbers or two integers, like a plus b is equal to b plus a. But here we can do a plus b plus c is same if I do a plus b plus c. For example, always we take an example with us when we try to understand these things. If I have three numbers like 3 plus 1 plus, I will take a negative integer also here, minus 5. So I will just do what is that I can do 3 plus 1 plus minus 5. I think I'm right. Now this thing is nothing but equal to 3 plus 1 plus minus 5 is nothing but minus 4, which is equal to 3 plus minus 4 is equal to minus 1. But now if I do like this, 3 plus 1 plus minus 5. So it will be, it was nothing but equal to 4 plus minus 5. And now you can see that the answer is minus 1. So I can say that A means I will just write 3 plus 1 plus minus 5 is uh, equal to 3, 3 plus 1, 1 plus minus 5. Yeah. We have learned 3. Now comes the fourth one. Fourth one is the additive identity. Now, what is additive identity? Some people also say it as addition by 0. This is nothing but A plus, sorry, it will go a little bit down, I think. I don't have an option to go down. So I think I will just take it a little bit up so that you can see it. A plus 0 is nothing but A, sorry, 0 plus A. Now, how do we say this? I'm just going to, I think I need to drag it something like here. 1 minute, I will shorten it up. So, I will do it over here. I think it's visible now. So, what I'm doing right now is additive identity. So, if, for example, I do 5 plus 0 is nothing but 5. Same if I do 0 plus 5 is nothing but 5. So I say that 5 plus 0 is equal to 0 plus 5. This was the fourth property, which is known as additive identity, or you can even say addition by 0. Now the fifth property and the last property, if you have another properties too, it can be, but I have only this much. It is called additive inverse. I think I will spell it. What is additive inverse? Additive inverse is that when you write A plus minus A only is always equal to 0. So it means that when you take an, like if I take number 5, so if I 5 plus the negative of it means minus 5. So I do 5 plus minus 5 is always equal to 0 because plus minus becomes minus and 5 minus 5 is 0. So I will take the same example here and I will do a little bit up. So I take 5 plus its negative. 5's negative is nothing but minus 5. So this thing is equal to 5 plus minus 5 is nothing but minus 5 minus 5 because the plus minus becomes the minus. So 5 plus minus 5 is equal to 0. So I hope you have understood what I mean by the properties of addition integers. Now comes the properties of subtraction. First property is closure property. So what is closure property? Closure property we have learned before also, that an integer minus integer means an integer subtracted by an integer is always an integer. For example, 4 minus 2. I'm taking 4 minus 2. So here 4 minus 2, 4 is an integer and minus 2 is even an integer. So 4 minus 2 is equal to 2. So I can now here, I think you understand what I'm trying to tell you. That integer minus an integer is always an integer. I will write second property. The second property is, now these properties is something which you need to understand. This is nothing but commutative property only. Now here you will think that this is nothing, this is wrong. But I just want you to understand that we say that commutative property in addition is like a plus b is equal to b plus a. And like now I will say that a minus b is equal to b minus a. But I want you to understand that, I will just write it, that a minus b is not equal to b minus a. Now how to prove it? For example, I have, I can say minus 5. Let's make it a bracket. And 1 minute. No, 5 minus 2. What do you understand by 5 minus 2? Means in by 5, 2 is taken away from 5, which is equal to 3. Now if I write like a minus b is equal to b minus a, if I write 2 minus 5, this is completely wrong. Why? Because 2 minus 5 is something equal to minus 3. I hope you understand. So 3 is not equal to minus 3. So now I prove you that the commutative property does not apply in subtraction. Third property is subtraction by 0, or you can say subtraction identity. I will write just subtraction by 0. Now what is subtraction by 0? If I write, now this will be wrong. If I write a minus 0 is not equal to 0 minus a. Now what is I am trying to tell you is that a minus 0 is not equal to 0 minus a. Now how to prove it? Maths need, if you're doing these things, it needs proof. You need to prove, you need to state that why you are saying that it's not equal. So if I from a, if I write 4 minus 0 is equal to 4. But if I write 0, 0 minus 4, it is equal to minus 4. So this is something we have just learned in commutative property, that 4 minus 0 is not equal to 0 minus 4. So I hope you understood this. Now I'm just going to tell you a last thing which I catched up in my book. Fourth thing, they have not named it yet. Like if A, B, and C are integers, simple are integers, then, are integers, and you need to understand the topic I am just telling you, and I think it will come over here. I'll just move it up, this thing up. I have this thing also. And here A is greater than B, then you need to understand that A minus C will be greater than the difference of B minus C. Now we will understand this also, because I told you maths, if you're doing maths, you need to prove it. For example, I would like to say that A is 4, B is 5, and C is 6. So 4, 5, 6. So 4, but we need to prove like that. So I will write 5, 4, 6. So 5 is greater than 4, then 5 minus 6 will be greater than 4 minus 6. So how do we prove it? You know, I will just 1 minute please. Do it over here. So 5 minus 6, everyone knows it's minus 1. It got a number minus 1. And now I need to prove it that minus 1 is greater than the number 4 minus 6. So 4 minus 6 is nothing but minus, 1 minute. 2. So if I go through number line, the smallest negative integer is always the biggest. Means if it's minus 1 will be the greatest integer. If it's minus 2 will be the smallest integer. So I proved it that if A, B, and C are integers and A is greater than B, then A minus C is greater than what will be B minus C. I hope you liked the video. Thank you.